So on the previous video, we did a lot of work on this, and I guess the moral of the story is always check and see if you could factor the old-fashioned way, where you factor, split, and solve. So instead of doing all that work, we know that what times what is positive 36, that if you combine together is b. That'll be a negative 9 and a negative 4. And since it equals 0, then you could actually say x minus 9 equals 0, x minus 4 equals 0. So your answer would be x equals 9, x equals 4. So always check and see if you could factor first, split, and solve the way we did the old way. Now, this one right here, you will not be able to do that. And again, you're going to end up with fractions. Or could you? Actually, you could. So you don't have to complete the square here either. What could you factor out of the left side? What could you factor out of the left side? What's in common here and here? X. So if you pull out an x, what's going to be left? X plus 3, and that's it. You guys agree? Now, once again, you could use the zero product property and say if you have this times this and it equals 0, then this could be 0 or this could be 0. So you could just split them and say x equals 0 and x plus 3 also could equal 0, which means that this is an answer already, and over here x will equal negative 3, so you get your two answers that way, and that's a heck of a lot faster than completing the square. If we take a look at number 17, this one could also be factored. You don't have to complete the square. Just do this and then split it and solve. Let's take a look at a different one here. 18. This one we could actually complete the square. You guys want to try it? All right, so let's first make sure that our A value is 1, which it is. Let's make space for our new C value. So we're going to go plus 13, plus 13. This cancels. You have a new equation that says x squared minus 4x blank spot equals 13 with the blank spot. What we need to do is take the B value. Take the B value, which is negative 4. We're going to take half of it, which is negative 2, and then we're going to square it. Negative 2 squared is positive 4. So you put a plus 4 here and a plus 4 over here. And now we'll be able to write it as a binomial squared. And you have an x in there, and then you simply take half of b, half of whatever you see here, which is a negative 4, half of that's negative 2. And that's your perfect square, or that's your binomial squared, equals 17. And now, of course, you apply a square root. You have x minus 2 equals plus or minus the square root of 17. And your final step would be to add 2 to both sides. Now you can't really add that, you're just going to rewrite it. So your final answer is x equals 2 plus or minus the square root of 17. So if that square root of 17 could be simplified, you have to simplify it, but 17, you cannot break it down, so that's your final answer. Okay, guys, number 20. Just because this says completing the square doesn't mean you have to do completing the square. You could try to do other methods. You guys remember that long process of multiplying A times C and then thinking of the multiples of that answer that combine together to give you the B value, and then you could do factoring by grouping. You could do that method on this one, but maybe we want to do completing the square just to challenge ourselves, right? So to complete the square, you want to make sure your A value is 1. So we're first going to have to do what? That's right. Divide by 3, divide by 3, divide by 3, divide by 3, everything by 3. So this is going to cancel. I will have x squared plus 2/3 x minus 1/3 equals 0. And then you want to make space for your new C value. So you're going to add 1/3, add 1/3. So you're going to have a new equation. It's going to be x squared plus 2/3 x blank spot equals 1/3 blank spot. So once again, I moved this old C value over to the other side. I now have space for my new perfect C value that I want to come up with. And of course I put a space over here because whatever I add on to here, I have to add on over here. So how do I find my perfect C value? I need to take the B value and take half of it. Okay? So this is where we need to go fall back on some old math skills. How do I take half of 2/3? Well, let me just do this on the side in blue. 2/3, if I want to take half of it, that's really multiplying it by 1/2. I mean, if you think about it, whenever you want to divide anything by 2, you could simply multiply it by 0.5 or multiply it by 1/2. It's the same thing as dividing by 2. So when I take 2/3 and I take half of it, what do I get?
1/3.
Notice that the 2's cancel. You're correct. It's 1/3. So that's 1/3. That's half of B. Now I still need to do what with it? I still need to square it. And that'll give me my perfect C value. Once again, these notes that I need to have in my head is B divided by 2 squared. So I took my B value, 2/3. I divided it by 2, but that's 2/3 times half. I got 1/3, and now I need to square it. And that's pretty easy to do. 1/3 squared is simply 1/3 times 1/3, which is really what? 1/9, right? So that's really 1/9. Okay, so my new perfect C value is 1/9, so I'm going to go plus 1/9 right here and plus 1/9 over here. Now the whole purpose, this was the work I did on the side right here to find my perfect C value. Let me go back to this. The whole purpose of finding this perfect C value is to be able to write it as a binomial squared equaling, I'll worry about the fraction addition later. But right now, what's my binomial squared going to be? It's going to be x and then simply half of 2/3. Now, what was half of 2/3? Over here we did it. 2/3 times half. What do we get? 1/3. So I really have plus 1/3 in here. No way. Yes, you guys are excited because of the 1/3. Anyway, on the right side over here, we have 1/3 plus 1/9. In order for us to add it, we need a common denominator. So I want to change that 3 to become a 9, and this one's already a 9. So I need the 3 to become a 9 by multiplying both top and bottom by 3. So I end up with 3/9. And I need to add 3/9 plus 1/9, and what do we get? 4/9. So I really have 4/9 on this side. And now I could apply a square root to get rid of the squared on the binomial. And what you do to one side, you do to the other side. So you will have x plus 1/3 equals plus or minus. I'm going to split the root to the 4 and to the 9 because both of them are perfect square numbers. So I will have x plus 1/3 equals plus or minus the fraction 2/3. All I need to do now is move the 1/3 over to the other side. So I'm going to have an answer. I'm running out of space here. I'm going to have an answer that says x equals negative 1/3 plus or minus 2/3. And this is really two answers. One answer is negative 1/3 plus 2/3. The other one's negative 1/3 minus 2/3. So the top one, negative 1/3 plus 2/3, what's our answer there? 1/3. That's right, 1/3. And on the bottom one, you end up with negative 3/3, which is really negative 1. And that's your other answer right there. So those are the two correct answers for number 20, 1/3 and negative 1. '23 is so easy, you might get confused. You have an x squared. All you got to do is get rid of that square. If you're solving, you want to get x by itself. How do you get rid of a square? Square root. What you do to one side, do to the other. You're going to have x equals, don't forget, when you apply a square root, you have to put a plus minus in front of your answer. And of course, the negative sign comes outside as an I value. And the square root of 11, if you could simplify it, you simplify it. But since you can't, that's your final answer. So let's do number 22 by completing the square. We're going to add 3 to both sides. So you're going to have x squared minus x blank spot equals 3 with the blank spot. How do you find this perfect C value? You simply look at your B value, which we all should see is -1, and you got to take half of -1, which is simply -half, and then you got to square it. Remember your notes. You have B divided by 2 squared. So think about that. -1 divided by 2 squared, that's really going to be -1/2 times -1/2. And that'll be your perfect C value of +1/4. So you're going to put a +1/4 right here. You're going to put a +1/4 over here. And now you'll be able to rewrite your trinomial, your perfect square trinomial, as a binomial squared. And it's going to equal 3 + 1/4. I guess you could write it as 3 1/4 for now. Or just leave it like that. But what's your binomial going to be? It's going to be x, and what's the b value, or what's the value that belongs inside the parentheses with the x? Half of this. And what's half of -1? It's simply -1/2. So over here on the right side, if you want to combine, we could put this over a 1, which 3 is really over 1, and you could get a common denominator of 4 to be able to add them if you'd like. So you would be multiplying this by 4, this by 4, you get 12 up on top plus 1/4, so you really get 13/4 on the right side. Now I'm going to apply a square root to both sides to get rid of the square. So I'm going to end up with x minus half equals, and I'm going to put a plus minus in front of my answer because I applied a square root. I'm going to split the square root and put the square root of 13 up on top. That's ugly. Let me change that. That's not going to work. Bear with me. Let me zoom in here and let me make this a nicer 13. Okay, and on the bottom I have the square root of 4. So this is my answer so far. I am going to add 1/2 and add 1/2. So my new answer will be x equals +1/2 plus or minus the square root of 13 over 2, because the square root of 4 is 2. And that's as far as you could go. Unless they put the fractions together, which they might have done. And looking at the answers on the back side, they actually did, right? You don't have to. What they did is since you have a common denominator, a 2 down here and a 2 down here, they decided to write everything over one single 2. So they put 1 plus or minus square root of 13 over 2. This is okay, but this one is just fine the way it is. Either answer is good. I'm done. You guys could keep working on this worksheet.